All-American season. Wait, All-American season? Is that like a football show or what is that, Antonio? Sound okay, for sure. Good, good. Tonight, so I like well, I don't know. I like a lot of stuff, but I also like sci-fi and fantasy stuff. And tonight on HBO, I believe the season premiere of season 3 of a show called Raised by Wolves is happening tonight. I've got a lot of work uh, to do for work, so I'm probably not going to get to watch it. But I really want to watch that when I get a chance. So Antonio, I'm also hoping you get your show All American Season on Netflix. All right, guys and folks, gals. Let's start off with some review questions from yesterday. Some of them are going to be the same. So, but this will be a good review for what did we remember from yesterday, um, as well as just in the past. So, slope of a line. I know you've already answered this to me yesterday, but let's do it again. How do you describe slope? What is slope? In your own words, best as you can. No judgment. There's not one right way to say it. There's lots of different ways. So I want to hear from all of you. How do you describe slope? What is slope? Slope of a line. So, pretend we've got some random line floating out in outer space. What is the slope of it? What does it mean to say the slope is 5 or -2 or whatever? All right, I see 3 of you have answered, or there's 3 comments. How steep it is, Braden? High five. Yes, sir. Steepness. Andrew, thank you. And Andrew, I'll check that out. The show. I'll check that out. So, yeah, it's the steepness of the line. All lines, like the red one I have on the screen, they've got some direction, right? You can make a different one here that's kind of going lower. So these both have different steepnesses. And slope is how we describe that steepness. My first line, it looks like it's steeper, right? It's like more of a harder climb if you were a little person here. This one's a harder climb. This one's more gradual. So this one would have a lower slope, a lower number. And this one would have a higher number slope compared to each other. Just remember, we measure slope as rise over run. So we always measure it like up and over. How far up, how far over, or if it's going downwards, like this guy, then it's how far down and over. But it's always to the right. This would be a negative slope here. Just some ideas, some thoughts to keep in mind. All right, next up. You all know this, I hope. What are parallel lines? What does it mean for lines to be parallel? How do you describe that? What are parallel lines? Go. I only heard from Braden and Andrew for the last question. I want to hear from all of you.
The lines are like close to each other.
Close to each other. Manaya, if they're close to each other and they cross, are they parallel?
No, they're it's the next question you're about to ask. I don't know the name to it though.
It's all good. I appreciate it. So if they're crossing, they can't be parallel. Is that right?
Yes.
Good. So that's one way to think about it. And a couple of you said that yesterday. They're lines that never cross. I think it was Aaron and maybe someone else said that yesterday. Braden today said lines that have the same slope. Oh, high five. 2 high fives at the same time. Yes, lines that have the same slope. Love it. So that means they have the same steepness, they have the same direction. They never cross, like Manaya is helping us remember. And then our last question is, what are perpendicular lines? So remember, these cross, but they cross in a special way. What does it mean for them to be perpendicular?
They make an X.
They make an X. That's a good way to think of it. They're crossing in a perfect X. Can we say anything? Can we use any vocab for how to describe that X? Is there anything special about the angle that they're
Don't
making
they
between?
cross? Don't they cross the x-axis or something like that?
That's one example, and we talked about it yesterday, the XY axis. It's going straight up and then straight left and right. So it makes perpendicular lines. Good. How do we describe this angle, folks? The angle that's created by these crossing perpendicular lines.
90 degrees.
Oh, Aaron and Braden, yes, 90 degrees or a right angle. Correct on both. You can call it either way. It's a right angle, or you could say it's a 90-degree angle. Same thing, okay? 90 degrees is a right angle. Good. Thanks, guys. Good. All right, now I added 2 more questions for today. Here we go. Think about this for a second. I want you to choose between the 2 underlined options. Do parallel lines have equal slopes or opposite reciprocal slopes? Do parallel lines have equal slopes or opposite reciprocals? Remember, parallels are the ones that go together. They have the same steepness. So are these equal slopes or opposite reciprocal?
Aren't they equal because it's the same length and everything?
I would, okay, yes, Manaya, they're equal because they're the same direction.
Okay.
Technically, these 2 lines go on forever. The little arrows at the end are supposed to symbolize that it's never stopping. So they don't have a length really, but they do have the same direction. Is that okay? Good, Braden. Equal slopes. So parallel lines have equal slopes. And then you know what the next one's going to be. Do perpendicular lines have equal slopes or opposite reciprocal slopes? Remember, these guys are going in totally different directions. They're crossing at a 90-degree angle. So do you think they have equal slopes or opposite reciprocal slopes?
I'm going to go ahead and say opposite reciprocal slopes.
Braden, that is a safe bet. I love it. Delaney, high five, opposite reciprocals, and then also Braden in the chat. Cool. So thanks to you two. Yeah, these have opposite reciprocal slopes. Okay, we need a bonus question here. Extra question. What is opposite reciprocal? What does that mean? Can anyone remember from yesterday? What does this mean, opposite reciprocal? How do you describe that? Reciprocal. What does that even mean? Help me out. I was just born today. I have no idea what this means. What does opposite reciprocal mean?
I won't lie, I don't totally remember, but isn't it where we flip where like we could flip the number and then make it negative when it goes on top?
Braden, you said you don't remember, but you answered it 100% correctly.
Okay, perfect.
Antonio with the example. I love it. 5 and negative 1/5. Let me put that up on the board. Here's an example, and it describes what Braden just said. It's 5 is one number. Its opposite reciprocal would be negative 1/5. Good job. So if we've got a whole number like a 5, make sure to flip that and it becomes 1/5. How about if we started with a fraction like 7/8, 7/8. This would become, flip it and change the sign. These are opposite reciprocals. Let me check the chat quick. Good job, Antonio. Thank you. Yes. All right, I think I've got a third question here. Let's see. I drew through it. The slope-intercept form of an equation is y equals mx plus b. What do the m and the b stand for? Can anyone tell me from yesterday? What does the m and the b in this equation here, what does that stand for? What do they mean? They stand for certain parts of the line on the graph when we graph our function. What does the m and the b stand for? No one remembers this?
The m is the slope and b is the y-intercept.
Aaron, 2 high fives. Boom. Thank you for taking a risk and answering out loud. M is the slope, B is the y-intercept. On our graph, if we were to have a function and we graphed it, remember y-intercept, that's where the function line, like the equation line, is crossing the y-axis. So here's my purple function. So this spot right here, that's my b number, the y-intercept. And the slope, how do we know that? Well, if we have 2 points, we're going to use our formula for it. We did that yesterday a bunch. If we don't have points, but we have our purple line, we can count the units up and over. Rise over run. Rise over run is slope. It's how we describe it. Those are numbers, right? So it'll be up 5 over 2, up 5 over 2, or something like that. The numbers will change. It just depends on how high up and then how over we're going. What else? What else? And I wanted to say this. The formula for slope that we used yesterday, remember? Y minus y over x minus x. See the y minus y over x minus x? That is the rise, y minus y divided by the run, x minus x. So that's what's going on with that formula when we use it. We're basically measuring the height. If 2 of us were standing next to each other, we could measure our the distance between us, like the distance between our heights, right? 2 of us are standing beside each other. One of us is taller than the other by some amount. So what we're doing with y minus y is measuring like my height and your height and subtracting them from each other. X minus x is measuring how far apart we are from each other on the floor. Rise divided by run. Just a quick review. Any questions on these questions or the last page? Comments? No. So we're going to just pick up where we left off yesterday. There's a couple more subtopics that are going to pop up in the mastery test. So most of the stuff we did yesterday is similar to what you're going to see on the mastery test, but I wanted to practice some of the harder ones with you. So you'd see what they're like. I'm going to change some of the numbers from what you see in the mastery test, but the problems are the same. The questions are the same. We're going to talk about a property of reciprocals. We'll do that in a second. And then later we're going to look at the perpendicular bisector because that comes up as a subtopic, okay? A sub-idea. Here we go. This question is from our mastery test that we're going to be doing today. I'm going to be like officially assigning it to you today. There we go. So, confusing looking graph and a word problem. So let's work this out together and see what's going on, see what we know, and then try to solve it. A software designer is mapping the streets for a new racing game. All the streets are depicted as either perpendicular or parallel lines. the equation of the lane passing through A and B is this. Negative 7x plus 3y equals negative 21.5. Let's check out our graph really quick. We see A here. We see B. We don't really know their points. We don't know their coordinates, right? But they are telling us that A and B, the equation for the line AB is this. Negative 7x plus 3y equals negative 21.5. They want us to answer what is the equation of the central street PQ. I'm going to cross that out. We're going to solve for a different line. So I'm going to label, you'll be able to solve this problem for PQ after doing the example, but I'm going to solve for, instead of PQ, let's solve for C to this 7, 7. I'm going to label that J. So that's point J now, okay? So we're going to solve for the equation for CJ, the equation for line CJ. Okay. Look at the picture. We've got QP or PQ, and notice how they're labeling PQ as perpendicular. This right angle right here, the green box, that's perpendicular to AB. That means the slope of AB, line AB, is opposite reciprocal to the slope of CJ and to PQ and to D and this spot, 7, 5. So they're telling us ahead of time that like the 3 lines in the middle, this one, and this one, these are parallel to each other. They're telling us that up top because everything is either parallel or perpendicular in the graph. So the slope of AB is perpendicular or opposite reciprocal to CJ. CJ is the one we're interested in for this question. So if we're supposed to come up with the equation, the y equals mx plus b for CJ, what do we need for this? What numbers do we need to fill in on our y equals mx plus b? We need m, we need b. Just like yesterday, we need the m, the slope, and we need the b, the y-intercept. They gave us the equation for AB. It's above in the writing, negative 7x plus 3y equals negative 21.5. Now, right now, look at that equation, the negative 7x plus 3y. Is that in slope-intercept form? Does it look like y equals mx plus b? Oh, I can't see if there's people chatting. Sorry, I took away the thing so I can't see the chat anymore. Okay, so forgive me. I can't see if there's anyone chatting right now because that thing was taking up too much space. It's not in slope-intercept form. Basically, we want our equation. I'm going to change to red. We want our equation to be y equals the rest of it. And looking at how they gave it to us, it's not like that, right? It's in negative 7x plus 3y. We want y to be all by itself. So we're going to start this by rearranging this equation in slope-intercept form. So we need to do a little bit of algebra. We need to get the negative 7x over to the right side, and then we're going to divide the whole equation by 3 so that the y will be all alone. So we add 7x to both sides. Negative 7x plus 7x, they're gone. We've got 3y equals 7x minus 21.5. It's starting to look more like slope-intercept form. Last step is to divide everything by 3. So that way the y is all alone and it'll be in the form we want. Okay, for this I'm going to divide in the calculator. 21.5 divided by 3. I've got negative 7.17. I'm going to round that up. If you did that, you've got 6's continuing forever. We're going to round it to 7.17. This is the line for AB, the line equation. Okay, can anyone tell me? I need you to do it with your mic. I'm sorry, because I can't do the chat right now. Can anyone tell me what is the slope of AB? Can you see it from the formula that I just found? What is the slope, the M for AB? Please.
7/3.
Thank you. 7/3. We want the slope for, back on the right side of the picture, we want this line, right? CJ. So we just found that the slope for AB is 7/3, 7/3. We're going to do opposite reciprocal of 7/3 is negative 3/7. That's the slope we're going to use for CJ. To find the equation now that we've got the M, this is the M for CJ, we need the B value, right? Look up top. Those are the two numbers we were trying to find for this problem. We need M and B. We've got M. To find B, we're going to take our blank version of y equals mx plus b. We plug in the slope we just found. We plug in x and y from CJ. It can be any point from CJ. Luckily, if you look at the graph, we have a point right here for J. We don't know what C is, but we know J is 7, 7. So 7 is going to be my Y, and 7 is going to be X, and we're solving this for B. Now, luckily, once we start simplifying this, we have 7 times negative 3/7, right? 7/7 cancels out right away, so that's nice and clean. 7 equals negative 3 plus b. Add a 3 to both sides. B is 10. Woohoo! So now we've got the two things we were looking for. We have our M and our B for CJ. So I'll write it up at the top right since we're running out of space. So the CJ equation, y equals negative 3/7 x plus 10. That's our answer. That's the equation. That's how I would want to work with it and graph it. I think the answers for this are back in standard form, not in slope-intercept form. So standard form is how the equation was given to us initially. So to put it into standard form, we're going to take the equation you just found and then rearrange it so that it's the x and the y together on the same side and there's no fractions. So if I were to add this 3/7 x to both sides and then multiply the whole thing by 7 to get rid of the fraction, we would have this. 3/7 x plus y equals 10. Multiply everything by 7. cancels out the fraction, 7 times everything. So it looks like it's going to be 3x plus 7y equals 70. These are in different forms, but what I've just boxed are the same line. If you entered both of those into Desmos and graphed them, it'd have the same line right on top of each other. They're just in different forms of writing it out. So really this problem, it's presented differently, but it's really the same kind of thing we were doing yesterday. They gave us a line and they asked for the equation of the line that's perpendicular to it through a certain point, through 7, 7, J. Okay, I'll hold here for a sec and then I want to start another problem. If you need more time, let me know. Okay, so let's talk about this real quick. A note about opposite reciprocals. We've been working with opposite reciprocals. You guys seem to be doing really well with defining it and then finding any numbers opposite reciprocal. But I haven't mentioned this yet. Any number times its opposite reciprocal always equals -1. Write this down in your notes. It's a concept about reciprocals that I haven't really stressed, but it's true, and this mastery test is going to use it a couple times. So let's try it out and see how this works. Let's start by picking any number. That's our starting number. Multiply that number to its opposite reciprocal. And then what does it equal? Let's try it out. Let's pick 8, and we're going to multiply that to its opposite reciprocal. I'm saying that every time we do this, we get -1. 8 over 8, what's left over? -1. Let's try a number that starts off negative in a fraction. So let's do -7/10. We're going to multiply this to its opposite reciprocal, positive 10 over 7. 10 over 10 cancels, 7 over 7, and what's left? -1. It's another way to define opposite reciprocals. You could say the opposite reciprocal is the number that you multiply to your starting number that makes -1. I don't really like that definition, but it's true, and we can use it when we need to. Any questions on this? You guys can still see my screen, right?
Yeah.
Okay. My bad. Sorry about the chat thing. I can't even see how to get it back. I need to practice this. My bad. All right. Let's go on. So we're going to use this concept in the next problem. So, and this one's kind of an interesting one, kind of fun, kind of theoretical. Let's check it out. The coordinates of A, B, and C in the diagram are, A is P, 4. Let's label it. So they're not telling us what the X value is. They're just labeling it P. B is 6, 1. And then C is 9Q. Again, they're not telling us that number. They're just calling it Q. Which equation correctly relates P and Q? So then we see our options on the right side. They're all little equations with P and Q and 7. Hint, since AB is perpendicular to BC, the slope of AB times the slope of BC is -1. And that's the concept I was just going over on the last screen. If we knew the slope of AB times its opposite reciprocal, like this, it would give us -1. So let's see what we can say about the slopes of AB and BC, even though the numbers are including like variables P and Q. So remember, slope formula is the y minus y over x minus x for the 2 points. So for AB, what would that give us? What's the y minus y for AB? Can anyone tell me? You can either tell me the number or what would the two numbers be? The y minus the other y. What should we write there for A and B?
4 and 1.
Beautiful, thank you. 4 and 1, so 4 minus 1. How about the x's? X minus x. We're looking at A and B. What are the x numbers that are given to us in the coordinates for A and B?
P and 6.
Yes. Good eye. Right here. That's where she got those. That's x and y. And same thing for B, x and y. So P minus 6. So my slope for AB is 4 minus 1 over P minus 6. We can clean it up a little bit because we can actually figure out what 4 minus 1 is. So we'll say it's 3 over P minus 6. I'm going to circle this, box it. Same questions for BC now. Slope of BC. Same idea. We're going to do y minus y over x minus x. This time we've got the q. Look at the point C. It's 9 comma q. So we're going to say q minus 1. That's y minus y over 9 minus 6. We can't deal with q minus 1 yet because we don't know what the number q is. So I'm just going to leave it as q minus 1, but 9 minus 6 is 3. Woohoo! And this is for BC. Slope. Now, we can't really write the equations for these guys because of the QP issue. But if we multiply together our two slopes, they equal -1. Why? Because they're perpendicular lines. So let's write that out now. So slope of AB, here's what the thought process is. Slope of AB times slope of BC equals -1 because they're opposite reciprocals. So let's plug in those fractions we found for the two slopes. 3 over P minus 6 times Q minus 1 over 3 equals -1. 3 over 3, 3 on the top times the 3 on the bottom. These guys get to cancel. So that's nice. And now we have Q minus 1 over P minus 6. And that's equal to -1. So now if we were to multiply both sides of this equation by P minus 6, we can clear out the fraction. Let me change my color here. On the left side, P minus 6 over P minus 6 cancels completely. And now we have Q minus 1 equals, we've got to distribute -1. We're going to change the sign of the P minus 6 on the right side. So negative P plus 6. And it looks like in the answers, they're grouping the Q and P together, so we need to do that. So we add P to both sides. So we've got P plus Q minus 1 equals 6. And if we add a 1 to both sides, we've got P plus Q equals 7. How did we do this? We knew that the slopes of the two lines would be opposite reciprocals, and therefore they multiply to make a -1. So we needed to set up this equation on the left side. I'm boxing it now. In order to set that up, we had to figure out, well, what is the slope of each of these two lines? And because they gave us the points, we were able to write the slope, even though they had P's and Q's in them. We can still write those slopes with P's and Q's, with unknowns, with variables. Okay, I'm going to move on unless there's any comments or concerns. And I apologize, I can't see the chat. So if you do, please just jump in and let me know verbally. Here we go. You know what? I want to do this one. We need to do this one, but I'm going to come back to it. Let's do this one next for time. A note on perpendicular bisectors. Okay. Perpendicular, we know what that means. Bisect, that means take some object and cut it in half, bisect it. So if we have an actual like finite line segment, earlier at the beginning, someone mentioned the lengths of lines, and regular lines go on forever. But if I know that I have endpoints between two, points like A and B here, I should be able to measure and find the direct middle right here. How do we find that bisector algebraically? We add up the 2 points and then divide by 2, basically. So here's an example. Let's say A is at 1, 2 on our graph, and B will be 10, 9. So to find the bisector point, we want that x and y. So to find that, we're going to add up the x's and divide by 2. We're finding the average or the mean of the x's, and then we're going to find the y's added up and divide those by 2, finding the mean of the y's. And that is the bisector of any segment. So we would get 1 plus 10 cut in half, and then we would get 2 plus 9 cut in half. Oh, I didn't mean to make those both 11. But let's try it out. So 1 plus 10 is 11 over 2. And 2 plus 9 is also 11 over 2. Okay, maybe it was a poor example. I didn't mean to make them come out to 11 each. That would give us 5.5, 5.5 for our bisector of this segment. I was just lucky. So what's the perpendicular bisector? That's the line that goes through the bisecting point and it's perpendicular to AB. So that would be this red line here. It's got to be perfectly perpendicular with a right angle, but it's going through that special spot right halfway between the 2 points A and B. So how does this relate to us? Perpendicular lines, opposite reciprocal slopes. So if we need to find a perpendicular bisector of something, we need the slope of AB so we can find its opposite reciprocal. And then we would use the bisector point 5.5, 5.5 to find the rest of the equation. I'll hold here for a sec, and then we'll try a problem that uses this. Okay. And, Edmentum, in its infinite glory and wisdom, has given us a really time-consuming problem to use with perpendicular bisectors. But you guys can do this if you take each one at a time. Take your time. So let's see what this wants. Arrange the pairs of points in order of the y-intercepts the B numbers, of their corresponding perpendicular bisectors, starting with the smallest, ending with the largest. So basically, we need to calculate the perpendicular bisector equations for each of these sets of points they gave us. And then we'll just arrange them from smallest to biggest in the chart. So we need the equations of the perpendicular bisectors for each of these sets of points in the blue. Bisectors of the given points. Let's start with the first one. I'm just going to number these guys 1, 2, and 3, and so on. So for number 1, between A and B, think of it like that last example. It's going some direction. Maybe it's not going this way, but let's just say it is for our model. Well, we are given the points -4, 5, and 8, 9. So we've got to figure out what's the bisector, what's the spot right in the middle, and then we have got to figure out what's the equation of the line that's perpendicular that goes through that spot. All right, so let's start by finding the bisector. I'm going to label that point C. So C, for this number 1, add the x's, divide by 2, add the y's, divide by 2. So -4 plus 8, divide by 2, and 5 plus 9, divide by 2. And what is that? 4 over 2 and 14 over 2. So that comes out to 2 over, or it's 2 comma 7, sorry. Cool. So now we need the line that is perpendicular to AB and goes through 2, 7. So again, this is the same concept we've been doing all of yesterday and today. It's just presented in a new, funky way. So let's figure out the slope of AB and then do its opposite reciprocal for the slope we'll be using. Slope of AB. Y minus y over x minus x. And we're doing AB, right? So it's 5 minus 9 over -4 minus 8. So that's -4 over -12. 4 over 12. Cancel those negatives. Remember, negative over negative cancels the negatives. And now this becomes 1 over 3, I believe. So the slope of AB is 1 over 3. Cool. So the slope that we want that goes through C that's perpendicular to AB is the opposite reciprocal, -3. That's our M. Time to write the equation. Y is equal to mx plus b. We just found slope. The point we're using is 2, 7. So that's -6. Add a 6. So that's b equals 13. Yikes. So the reason we want the b is because they're asking us to arrange the stuff in the boxes. The smallest b ending with the largest b. They want us to arrange it in order of the y-intercepts, the b's. So the b value for number 1 was 13. We had to find 2, 7 though, because we knew it was bisecting A and B. And then after that, we needed slope, opposite reciprocal find the equation, so we could find the B number and start arranging them. So before we put these into the boxes, we would have to solve all of them.
I'm over here thinking that we were just gonna do like find the point, and then that was it. Like that's what I was thinking when we first started this.
Aaron, that's what I would have liked to have the question be, honestly. Because this is crazy. It's crazy. So today's Thursday, unfortunately. I would like everyone to do the mastery test today / this weekend. Depending on what I see on Monday morning, we might go through them or have time to get a lot of help on it on Monday. The questions all do revolve around like the same process that we've been doing, which is perpendicular lines, slopes, find the equation, right? But they're all worded a little differently, and this one is crazy. So just like you said, Aaron, finding the point, not too bad, 2,7. We found the midpoint of A and B. But then they want us to basically do the whole equation to get to that 13, the B number, because it's saying the order of the y-intercepts. Let's see. We've only got a little less than 10 minutes left. So I'm wondering if we should do more of this exact problem. Would you guys like to see more of this? Or should we look at a different like type of problem? If you don't mind voting verbally, since I've lost my chat, I want to do what you guys decide. Does anyone want to do more of this problem on the screen, or do you want to look at a different style?
Different style.
Different style. Thanks, Benaya. Anyone else have a preference? Same one here or a different style problem?
I agree. I think we should do another one.
Aaron, do you mean of this one on the screen or a different problem?
A different problem.
Got it. Okay. So far, that's 2 votes there. I'm going to, unless anyone else wants to vote, which I want you to do. I know verbal sucks because now people have to, know who voted. I'm sorry. You guys are good sports. Let's do a different type of problem. Really, this is a quick one, even though it doesn't look like it. So let's try to do both. So here's this problem. It's a proof. You guys have seen proofs before. What we need to do, though, is just fill in what goes here. Let's look at the question below. The table shows the proof of the relationship between the slopes of 2 perpendicular lines. What is missing? What is the missing statement from step 2? Look at the answers that they give you. They're all proportions, which is what we were doing last week, writing proportions for similar triangles. This question, it's a great test question, but honestly, it's not really on point for what we're doing this lesson or this week, because this is a similar triangles question, writing proportions. So I wanted to quickly show you that it's in the test. But the good news is it's not really like complicated for solving for any equations. It's just writing the proportions. So how can we write the proportions so that it works? We have similar triangles in the picture to the right, ABC and CDE. Why are they similar? Well, they're right triangles. And, it's telling us in the beginning right here. Triangle ABC is similar to CED. Cool. So since they're similar, we're going to write proportions that match their sides. So when we're doing a proof, it's useful to look and see kind of like the next step below right here in step 3 and see what they're using. So notice that they've got AB over BC and they've got ED over CE. So our answer is probably going to be using those same mixes of the sides, like AB and BC together, and so forth. So we check our answers and see, okay, can we eliminate any that aren't in those same setups, A, B, and B, C? I see that one here. This one, option B, is not the same setup. This one is. And then D is not. Again, it has AB with CE. So let's look at A and B, or I'm sorry, A and C, options A and C, and make sure that those proportions line up with the sides of the triangles in the correct way. So option A, AB is the little side over the other side that's not the hypotenuse, not the diagonal. So little over like medium. So is ED little over medium? ED is actually my medium side, and CE is my small side. So I think we're going to go with option C because that is the same order of naming them. Remember, from similar triangles, we've got to name them in the same order when we do our proportions. So AB is like small, and then BC is medium. CE is also small, and then ED is medium. So that's what this question was talking about. Oh, there's my chat box. Make sure when we're doing proportions to use the same order when you're labeling sides and stuff. So if we mix up the order, it's not true anymore. You have to do it in the same order. Small over medium equals small over medium. Okay, let's get this out of here. Let's check out this problem. We're not going to be able to do the entire thing, but it's okay. We'll get started like the other one. And then I'll let you guys go. Match each pair of points to the equation of the line that is parallel to the line passing through the points. So if you look at the blue boxes, we've got points and we've got equations, points and equations. We're supposed to match them up based on parallel lines. So I think this one is a little easier than the last matching question because we just need to make sure that the slope are equal. Slope is the number multiplied to the x. So here's all of our slopes. I underlined them. So let's take one of the points like this one here, B and C. I'm going to start with this top left. We need to find the slope of this, and it should match with one of the slopes in the equations below. Y minus y over x minus x. 2 minus negative 5 over 5 minus 7. 2 minus negative 5 minus a negative turns into plus. So it's 2 plus 5 over 5 minus 7, which is negative 2. So we've got 7 over negative 2. And if you divide that, you get negative 3.5. And lo and behold, that is the slope over here. Negative 3.5. I don't see it repeated anywhere else, so we should be done. So that means these two are a match. The wording is very confusing, so just be careful and pay attention when you're reading because as we saw with the other matching and this one, the wording is like the confusing part, I think, knowing what it is they're asking us to do. The equation of the line that is parallel, that was our key word here. Parallel means equal slopes. So we're going to just find the slopes for all the points and match them up to the equations that have the same slope. Okay.